So we're going to look at question number 4 from 2.9. We addressed question 1 in the Zoom class today. I realize several of you were not able to attend for various reasons, but I did have a question about could maybe I show you how to do number 4 since you have to repeat it several times over. So I'm going to show you question 4 in its entirety, and then you will be able to do questions 5, 6, 7, and 8 maybe. I think that's where it ends. But they're all based off this same information. The question that's presented to you in number 4, you're given the 5 starters on a starting lineup for the 2008-2009 Los Angeles Lakers. The players are listed in column 1, their position in column 2, and their height in column 3. The letters out next to each one of their names, I use those letters to make creating my samples easier instead of writing out their name every time. And we're just going to go ahead and do part A, where it says find the population mean height of the 5 players. We will go to Google Sheets to do this. I have not created a tab yet for the mean heights, but I will type that in right here so that we can get that. So let's see, population mean. And let me readjust my column width here. Okay, so the population mean is going to be equal to the sum of all the heights. Since I don't have them listed individually, I'm just going to go ahead and type each one of them in as a sum. So 73 and 84, and then divide that by 5, and we get a population mean of 79.8 inches. Okay, so the mean of the height of all the 5 players on this particular starting roster is 79.8 inches. So that's your answer to part A. Part B is to create a table of samples of size 2 indicating the mean for each sample. This is very similar to question number 1 that we reviewed in the Zoom class today. But again, like I said, several of you weren't able to be there. So right here you have, I've listed the sample groups. This is every possible sample of size 2 from our 5 players. So first sample is TK, and then we have TA, TD, TP. And remember, those letters refer back to individual players on the team. And then I've created 2 columns. The first column there in B is the height of the first player listed in the sample group. Column C is the height of the second player listed in the sample group. So T is 80 inches, K is 78 inches, and on down the list. We want to calculate the sample means for each one of these. So for the sample mean, you just type in equals. We're going to, average. And we're going to average these 2 values together. We get 79 inches there. We can drag that down, and this gives us the sample mean for every sample of size 2. Remember one thing we talked about in 2.10, even though it doesn't relate to this, the mean of all of these sample means will be equal to the population mean. I'm not going to calculate that now. It's not relevant to this assignment. So that should be the answer to part B. Create a table of samples of size 2 indicating the mean for each sample. So that's all you have to do right here is this, what I have in column D, the sample means. So that answers part B. Part C, for a random sample of size 2, what is the chance that the sample mean will equal the population mean? All you have to do at this point is go down this list of sample means right through here and see if any of them equal the population mean. Well, if you look, there is not a single sample mean that is equal to the population mean. So that is 0 out of 10, which is just a 0 probability that a randomly selected sample of 2 players will equal the population mean. For part D, for a random sample of size 2, obtain the probability that the sampling error made in estimating the population mean by the sample mean will be 1 inch or less. What we're doing for this part, we take our population mean and we are creating now a range. So our first value would be 1 inch less than the population mean, so it's 78.8. And then the other upper bound would be 1 inch greater than the population mean, which would be 80.8. So we're looking for any values that fall between 78.8 and 80.8, because that would give us every sample mean that is 1 inch less than the population mean up to 1 inch greater than the population mean. So 79 falls in that category. Let's see, what else do we have? 81 does not. That's it. 79 is the only one, because 82 is greater than our upper bound, 76.5 is less than our lower bound, 82 is greater than, 81 is greater than, 75.5 is less than, 81 is greater than, 78.5 is just slightly less than, 84 is greater than, 78.5 again is less than. So 79 is the only value that falls within that range. So it is 1 over 10, which is 0.1. That's the probability. As a percentage, it would be 10%. And that's all you have to do for question number 4. For question, let's see, 5, 6, 7, and I think maybe 8. All the samples of size 1, maybe I should have listed those for you. N equals 1, T, K, A, D, P. Okay. So samples of size 1, what I've done here is I've given you all the possible samples. That way you don't have to figure them out. Isn't that nice of me? So samples of size 1 is just T, K, A, D, and P. So you'll create the table again. For samples of size 3, these are all the possible samples of size 3 that you could have with those 5 players. And then samples of size 4, and then samples of size 5. So that should save you a little bit of work on question number 4. All you have to do is come up with the heights and all the sample means. But I hope that this clears that up. If you weren't able to participate in the Zoom class today, questions 1, 2, and 3 will be conducted in the same fashion. It's just you're not using hard data. You're just using some numbers that have been thrown out there for you to practice with. Keep the questions coming, guys. If you have any more, just ask me. I'll be happy to answer them. You guys take care.